Welcome to this video lecture on the subject electronic circuits. So we are going to discuss about the operating point. So first of all, we need to discuss the DC load line. So for need to understanding the operating point, here the load line is the locus of operating point on the output characteristics of the transistor. So, what is maybe output characteristic? It is the graph drawn between the collector current and collector to emitter voltages. So, as shown in this first diagram, which denotes the output characteristics. And a line on which the operating point moves according to the input AC signal is the load line. And for the circuit we are taken the values of IC and VCC, and the point A and B are marked as the VCC on the x-axis and B on the y-axis as VCC divided by RL. Here the cutoff region is near the point A, and saturation region is near the point B, and active region is in between the E and D. So the operating region, there are three regions: cutoff, saturation and active region. For the cutoff region, the transistor is in off state, and saturation region, the transistor is fully on. And in the active region, Q point is center of the load line, in which the transistor acts as the amplifier. So for this we need to bias the transistor in the emitter base junction as forward biased and collector base junction as the reverse bias, so that the transistor acts in the active region. And selection of operating point: when we select the operating point near the cutoff region, the signal will be distorted. For example, consider the collector current. Here the negative half of the signal is clipped off, and also in the near saturation, consider the waveform of collector current. Here the positive half is clipped off, and in the active region, near the active region, Q point is chosen so that we get the signal without any distortion. So to act the transistor perfectly as an amplifier, we need to stabilize the operating point in the center of the load line, that is in the active region. So this is the main reason for choosing the operating point in the middle of the transistor load line. And we can define the operating point as the quotient point. It is the point on the load line which represents the DC value of collector to emitter voltage and collector current in the absence of the signal. Best position is midpoint on the line, that is VCE equal to half of VCC. So for transistor amplifiers, the resulting DC current and voltage establish an operating point on the characteristics that define the region that will be employed for amplification of the applied signal. So since the operating point is fixed point, it is also called as the quotient point. Means it is stable. So quotient means quiet, still and inactive. So it can be seen on the general output characteristics. And what is the need for an operating point? The temperature causes the device parameters such as the transistor current gain, transistor leakage current to change. So we have already discussed in the stability, that is there are three parameters. One is beta, IC naught and VBE. So these three parameters changes with respect to temperature. So higher temperatures result in the increased leakage current in the device, so thereby changing the operating conditions set by the bias network. So the result is that the network design must also provide a degree of temperature stability so that the temperature changes result in minimum changes in the operating point. So the maintenance of the operating point can be specified by the stability factor. So for example, we can apply this to the CE configuration. For VCC equal to 10 volt, RC equal to 8K. Draw the DC load line. So find the Q point for the zero signal if base current is 15 microamps and beta equal to 40. For this we need to calculate the collector current, and also we need to calculate the VCE, that is collector to emitter voltage. So then we can draw the DC load line and also Q point. And assessment questions, define operating point. So it is the point on the load line which represents the DC value of VCE and IC in the absence of the signal. So best position is midpoint on load line, VCE equal to half VCC. So thank you for listening this lecture.